Hi, in the previous lecture we have discussed about the dot product of the vector and the orthogonality as well. In that lecture we are going to discuss the vector product and the cross product. If you want to have some study material, our study materials, you can download it from our website. We'll put the link of our website in our description box. Look at the scenario. There is something, let's consider some mechanics or losing up a bolt by a wrench. Okay, there is a force acting toward this side, and the length of the range. Now if you can observe, you can see that if this r is enlarged a little bit, then you will face a little bit easier to losing up the bolt, or if it or even in the case of the tightening, it follows the same. So there is something that will help you to do this. What that this r cross f, it will provide a torque is the reason of creating a rotational motion. Okay, torque is kind of the force for creating a rotational motion. So when it is created, when you apply two different force in, they are in a cross. Okay, and what will be the direction? The direction is upward. You might understand the right hand thumb rules and these all. So from there you can see that is upward. Exactly this concept, actually we use this concept to understand the cross product. Let's understand the cross product. The first thing is the definition. How we define the cross product? As we have defined the dot product as a dot b is equal to mod of a mod of b and cos theta of that. The theta is angle between two vectors a and b, but for the cross product scenario, it is sine theta. And as we have seen that dot product does not have any direction, so that the result of the dot product is always a scalar. But for the cross product, the result of a cross product is not a scalar. It is actually it is actually a vector, so it must have a direction. What is the direction? If you are doing if these two vector a and b, and you are finding the resultant c, the c will be perpendicular to both of the vector a and b. It is our definition of a cross product. Okay, basically geometrical definition of a cross product. Now the cross product is on a more interesting thing. If you see, you can see, and cross product of two vector is always present the magnitude, and the magnitude of the cross product is always represent area of a parallelogram. Suppose this is a area of a and that is the b. Okay, now how it is represent the area of a parallelogram? When we do the cross product, we will see that a b, we are not putting the magnitude, but these are not vector as well. Sine theta. Okay, now what is the area of a parallelogram is base into the height. Okay, now what happened when we do this? This is the height is equal to, if it is theta, height is equal to b sine theta. So what is the total base? A into b sine theta. So that is our cross product, and that is also the area of parallelogram. Now what is the different thing is this is the area, that is the magnitude, but it is not enough for a vector product or cross product. Magnitude is not enough for a cross product, so it must have a direction. In which way? If that a and b in a plane of z and y, then the direction will toward the x-axis, outward from that page. If you draw a page, parallelogram in a page, then the outward from the page will be the direction of that vector. Okay, now look at, you can see that some properties of a cross product. Okay, now what is the properties? Anti-commutativity. The first thing is, once you learn the vector calculate to cross product, you can verify these rules by yourself by using that calculation. But right now you can see, if b cross a, that does not mean that is does not equal to a cross b, because when you change, the direction also be changed, reversing the order, it will result, the resulting vector will be flips to the 180-degree, exact opposite. Okay, so b cross a is equal to minus a cross b. It does not follow commutativity, as you have seen in our previous lecture. In the dot product, b dot a and a dot b would be same, but here in that case it is not. B cross a is not is equal to a cross b. B cross a is equal to minus a cross b, so it does not follow commutativity. And distributive property, the cross product also follow the distributive property, like something look like that, a cross b plus c. You can do this a cross b plus a cross c, and if k is an scalar and you multiply it with a cross b, you can multiply with any of the vector and do it the rest, and you can, the rest of the left vector you can cross product with that. Okay, these are the vectors, and these also a vector, a cross k into k b. Okay, now unit vector, here calculating the unit vector is most important to calculate a cross product, because it will be huge, it will be a huge labor work to do a cross product. So the first thing is how to find the how unit vector can be calculated in a cross product. Like a cross product is, as we have seen, that a cross product is about the sine theta, and the value of, if the value of the theta is 0, then it gives us the 0 as well. So for the parallel vector means, or the for same kind of vector, a vector with the same direction, the angle between them will be also theta, will be also 0. So for the parallel vector, it will gives always you the result 0. So like if you are doing with the unit vector ex into e cross ex, that ex is the unit vector along x-axis, it will gives you 0. For the same for the uy and same for the ez, but it will not give you the 0 if it is not the parallel vector. Instead of it, if it is a perpendicular vector, the resultant will be perpendicular, but with the both of them, something like this ex uy, it is along with the x-axis, unit vector along with the y-axis. If you multiply that, finding cross product, you will get z, and it will be like a circle, like x is there, y is there, uh, and z is there. So it will give you always the next of the circle. If you multiply with the x and y, it will gives you z. If you multiply y and z, it will give you x, and if you z and x, it will give you y. Okay, but what if something not from them? What if it is doing in the reverse cycle, something that ez into uy, ez, you know, ex, but if you reverse, the result will be 180-degree opposite, so it will be ex. Same for all that things. If you change their position, means if you change their y and their x, it will be minus ez. If you ez cross ey, will be minus ex, and ex cross ez, will be minus uy. Okay, now as you have learned the calculate unit vector, learn to calculate the unit vector in cross product, you can now calculate the entire cross product as well. Let's see an cross product. Suppose this is a cross product. Okay, this is a cross product of a cross B. Here we can put it into the component, and B, if we split into the component, we get that Bx, Ex, By, Ey, Bz, Ez. This Ex, Ey, Ez are the unit vector. Okay. Now we can multiply it in the way. Suppose we are doing a cross product, so it will be the first term will Ax, Ax, Bx, Ex, Ex. Okay. Ax, By, Ex, Ey, Ax, Bz, and in the same way we can do entire things, that Ay, Bx, Ay, By, Az, Bz, and the important thing is that unit vector along with that. For the first scenario we will see Ex cross Ex, as we have in the from our previous slide. You can see that Ex and Ex, for the parallel vector, that cross product will give you the 0. So this term Ax, Bx will be eliminated, and that term Ay, By also will be eliminated, and Az, Bz also eliminated, because these are the same terms. For now, what are the not the same terms? That xy, as I have told you, that for the it is forward cyclic way, it will gives you that Ex, Ey. This means Ez. Okay, now Ex, Ez, for forward cyclic you can draw, if you face problem, Y, Z, and now for forward cyclic, for Ex, Ey, you get Ez. Now Ex, Ez, so this is a reverse cyclic, so it will give you Ey but minus form. Okay. Now Ex, that is also reverse cyclic, that will gives you the minus Ez. Okay, it will be eliminated. Ui, same parallel vector, it will be not there. And now Eyez, that is Ex. Okay, and Ezex will be simply Ey, it is no need of minus. Ezey, that is minus Ex, minus of Ex. So minus of Ex. Okay, now if you put one thing, that if you take Ex as a common, so what will Ay, Bz, and minus Az minus By. If you can see this, Ay, Bz minus Az minus By. Same way you can put, you have find that X component. Now let's find the Y component. It is minus, so we will put there later. That is Az, Bx, Ui, and Ax, Bz. That is Y component. Same way you can find the Z component. Where is Z component? Here is Ax, By minus another Z component. Can I see? Ay, Bx. So we get the cross product, and that is some hectic and long process to find the solution of the cross product. Later when we learn the levi-civita, we will see that it is not that much difficult to solving a cross product, but it is a formal method. A lot of labor work or hard work need to solve a cross product in that way. Now what we have get the answer, you can put that result into the determinant form, like we have get Ay, Bz minus Az, By, Ex minus of Ax, Bz minus Az, Bx, Ui, and that was our three component, and that was our result of our cross product. Okay, now you can see that you can write this cross product into the determinant form. Now by what will help you by writing the in the determinant form, many times you don't need, you don't have to always solve an entire product to get a result. Sometimes only finding the determinant you will get the result. But one more thing, we can do a levi-civita by using levi-civita symbol. Okay, now let's be frank, levi-civita symbol is not I cannot say levi-civita symbol is tremendous important for you. It is not, it is not at all tremendous important for you, but it is very interesting, and it might be very helpful for you, because a long, very long hard work, labor work can put into a very easy smart work through the levi-civita symbol. Once Albert Einstein was asked what he most loves about Italy, and he answered two things: kind of one kind of pasta, he replied, and another was levi-civita. Levi-civita was a mathematician who formalized this into a way that we can easily get the product. And when we have to do more than a three cross product, like four vectors are there and we are finding a cross product, it will be more hectic for us. But levi-civita will help us this much levi-civita will reduce that much more labor work. Okay, before levi-civita we are talking about Kronecker delta. You might think that what is the use of Kronecker delta in that lecture. Well, but in the next lecture you will understand why Kronecker delta is also important with the levi-civita symbol. So we are not explaining the Kronecker delta, levi-civita too much. We are just telling you the working rules of these two things. The Kronecker delta, the del ij is equal to 1 when that I and j will be the same. If these two terms are the same, then it will give always 1, and if it is not, then it will be 0. It is like the gate system. Okay, if the both are the same, it will be switch is on, and if not, then switch is off. Okay, but levi-civita is also an interesting thing, like how this is 1 2 3 you see are seeing, these are our axis actually. As we have discussed that x y z is our axis, in levi-civita we will consider our axis as 1 2 3. Okay, and now if you see your axis 1 2 3, it is a forward cyclic. Like what can be a forward cyclic? Epsilon 1 to 3 can be a forward cyclic. Epsilon 2 3 1 is also a forward cyclic. Epsilon from 3 1 2 is also a forward cyclic. These three are all forward cyclic. This forward cyclic, when epsilon will be a forward cyclic, it always gives you 1 plus 1, and it is, if it is the backward cyclic, then it will be gives you always minus 1. Backward cyclic what could be? Epsilon backward cyclic, 3 to 1 is a backward cyclic. Epsilon 2 1 3 is a backward cyclic, and epsilon let's start with 1 1 3 2, it is also a backward cyclic. Every time you see a epsilon backward cyclic, it will give you minus 1. Every time plus forward cyclic, it will give you minus plus 1, and every time it is backward cyclic, it will give you minus 1. And in case of repetition, means if you see that epsilon 1 1 2 or epsilon 2 2 1 or epsilon 3 1 3, these kind of are the things what are the where two coordinates are repeated, there it will gives the epsilon value of this epsilon will be gives you the 0. Okay, now we know when the levi-civita gives us the epsilon gives us the plus 1, when gives us minus 1, and when it is 0. Okay, now let's understand the cross product through the levi-civita symbol. It is our fundamental equation to find the cross product from the levi-civita symbol. What we in the levi-civita will not find the entire solution at all. We'll find only one component at a time. Like this is, we are doing that I component, a cross b, for only we are solving for the I component. So how, what is the our main equation, that if sum of j1 to 3, sum of k1 to 3, epsilon ijk aj bk. Okay, from here we can find the cross product as well. Let's see how. Here one thing here, instead of x, we will consider the our axis or the our ideal coordinate system as 1 2 3. Well, now if we do that, epsilon ijk aj bk, what we will see that here when ijk all three are 1 and a1 b1, when ij is 1 but k is 2, when ij was 1 but k is 3, that one a1 b3. okay, it gives you, but it gives you and you can see that and find all the 9 terms here for this epsilon. So but interesting thing is, in the previous slide we have seen that there it does not, epsilon does not, that levi-civita does not allow the repeated terms in epsilon. So here it is 1 1, so it will be not there, it will be 0. It is 1 2 1 1 2, it is also repeated term. Here is also repeated 2 times. It is 2 times 1, it is repeated times, 2 times 2, it is repeated times. It does not repeated. Epsilon 1 to 3 a to b3 is not repeated. So it is one of our terms we have. 1 3 is also repeated term, so it will be not also our anything we can do with this. 1 3 2, it is also another term that does not repeat. So our two terms is epsilon 1 to 3 and 1 3 2. When 1 to 3 is there, that is forward cyclic 1 to 3. So for forward cyclic it is plus 1 and plus 1 a to b3. So we get a to b3 is our forward cyclic, and that is a3 b2. It is 1 3 2, it is backward cyclic, that gives you the minus 1. So a3 b2. Now it is the result of the cross product in the ith component, means the first coordinate component if you are talking about x component. Now for a second you can think of that instead of 1 to 3, you can think that your x is equal to 1, y is equal to 2 and z is equal to 3. Then you can see what is your result of the component of the x component along with the ex. Actually what you have done is ay bz minus az by ex. Okay, now you can see if you can see your originally your originally resulted that product of ay bz minus az by. okay, what you have find in through the ay bz minus az by, that is, so this gives you the result of the product, and it is in quietly in easy form, not that much complex form. Now another identity, we say that Lagrange's identity. How can we just do that? We can find that AB and mod of A cross B mod of their square is, you can say that entire square A square B square sin square theta. You can do easily sin square theta is equal to 1 minus cos square theta. Now this a square b square minus a square b square cos theta. Now look, if you see this is the dot product. So the final result of your will be a cross b is, square is equal to a square b square minus a dot b entirely square. Okay, that is this is called our Lagrangian identity. Now there is a problem for us that if you put a force is in that 0 ex 10 uy, that means only in that direction, y direction, there is a some force component, and the position for the position is only x direction. So what is the cross multiplication? Exx, that these all will be vanished out, only 0.2 into 10 r into f into 10 ey ex will be uy r, sorry, we are doing r cross f, so ex ey, otherwise the symbol, the sign will be changed, minus. Okay, so ex ey will be ez, so it will be 2 ez. Okay, and newton per meter, as it is the unit. And another example is the, if you see that, find a cross a, what will we get? Technically it should be 0, because the first thing we have talked that it will be always gives you the theta, and theta will be 0, so it will be 0 for the first instance. You can see in that way. But another instance, if you set, you can find the levi-civita of this, you will see that their terms will be 1 to 3 a2 a3 and 1 to 3 epsilon 1 to 1 3 to a3 a2. Now look at this, a2 a3 and a3 a2 are the same, and if this is the minus a3 2 is it is a forward cyclic and it is reverse cyclic, so reverse cyclic will give you the minus, so the result will be just 0. Thank you so much for the lecture. We'll see you in the next lecture. For that study material you can download and from our website, and you can also give us the feedback what you can, how we can improve our lecture series. Thank you so much.
वीडियोस बनाने हैं, फिल्मोरा है ना।